Good afternoon and welcome to MHPN's May webinar. We're very excited to have everyone here today as we learn from Tom Nihil on this presentation called A Better Way to Assess the Capacity of Our Wooden Built Heritage, Guide to the Structural Evaluation of Existing Timber Structures. My name is Mallory Bauer, and I have the privilege of serving as the Education and Communications Manager for the Michigan Historic Preservation Network. Great, we can go to the next slide. Thank you. So many of us are getting very familiar with Zoom, but I just want to go over a few brief tips to maximize your participation so you can get the most out of your experience today. We will be collecting questions in the Q&A box. This function is in the toolbox or the toolbar, which should be at the bottom of your screen. If you don't see one, wiggle your mouse and it'll pop up. Sometimes it disappears. And there will be two little comic book blurbs. It says Q&A. Click on that and you can type in your question there. You can enter your question whenever you think about it. If it's in the middle of the presentation, we encourage you to put that in the Q&A box, but we are going to be holding questions until the end of the presentation. The chat window will also be available. We have some links to internet resources that we will share there. And if you're having technical difficulties or have a question about Zoom that you would like me to engage with, please put that there. We will have one poll, so please participate in that when it comes available. And there is also a survey at the end of the webinar that will pop up. If you would like to take a few moments to complete that this afternoon, or that link will go out in our follow-up email and you can take a moment to participate in the survey then. We do appreciate your time completing this information and providing feedback for us because we do use that to create future educational opportunities based on your suggestions. So thank you. All right, next slide. If you are unfamiliar with the Michigan Historic Preservation Network, I'll take a moment to introduce us. We are the statewide nonprofit that educates and advocates on behalf of historic preservation in Michigan. Our mission is to advocate for Michigan's historic places, to contribute to our economic vitality, sense of place, and connection to the past. We are a membership-driven organization, so if you would like to be a part of our work, I encourage you to check out our website, which is www.mhpn.org, and join us today. Also, we have our conference next week, our annual conference. It is going to be virtual this year, so you can participate from where you're sitting right now. It's going to be a phenomenal conference. We have a great lineup, so you can check that out also at our website. And registration is open through the conference. It will be recorded, and registrants will have access to those recordings through the end of the year as well. So I encourage you to go check that out. Next slide. And then I just want to take a moment to thank our generous supporters of these webinar series that we have been doing, the Michigan Council for Arts and Cultural Affairs and the National Trust for Historic Preservation. Thank you so much for supporting these opportunities so we can provide this content to everybody and spread the word about historic preservation. All right, so before I introduce our speaker this afternoon, I am going to launch this poll. So if you can select what best represents yourself and hit submit, we are asking, in what capacity are you involved in historic preservation activities? So are you an architect, a developer, tradesperson, engineer, an owner of a property, contractor, preservation consultant, or other? You may see yourself in several of these roles. There's only capacity to answer one, so select which one is maybe the role that you're interested in coming to this presentation. All right. Hit submit if you're thinking about it. Otherwise, I am going to close this poll and share the results. So we have 12% architects. We don't have any developers with us today. We have 4% are tradespeople, 16% engineers, 36% owner of a property. So that's our highest category. We have 0% contractors, 8% preservation consultant, and 24% identified as an other role not listed. So excellent. Thank you for doing that. That provides some information for us. So without further ado, I am going to introduce our presenter today. Tom Niehill is a professional structural engineer in Kalamazoo, Michigan, where he specializes in evaluation, preservation, and adaptive use of historic buildings. Tom is a member of the Timber Frame Engineering Council that is part of the Timber Framers Guild. He chairs the Timber Grading Training Committee for the council, and he is a member of the Michigan Historic Preservation Network, the Michigan Barn Preservation Network, and the Association for Preservation Technology, among other professional organizations. Tom is a regular instructor at Tillers International in Kalamazoo, where he teaches wood species identification, timber frame design, and traditional stone masonry. He has been a presenter and a workshop leader at prior MHPN conferences, and we thank him for his continued support and time this afternoon to share this information with us. So Tom, take it away.
Okay, very good. Thank you, Mallory. Let's wake up the computer. Here we go. Thanks everybody for joining here today. I saw a few familiar names in the list of attendees. Thanks for joining in. I'm very happy to be able to share with you some stuff. I've been on a bit of a mission to get the word out about this document that we call the Guide to Structural Evaluation of Existing Timber Structures, because it is so significant in the advance it makes in our ability to make a fair evaluation of the capacity of existing buildings. And so it really provides us with a better way of doing our job. I see we have a lot of owners, and I'll just fill you in a little bit on the background. As we engineers come to existing timber structures, we bring along our normal education, our normal tools for designing wood, which includes the National Design Specification for wood construction and the grading rules and all the associated allowable stresses that we use to design new buildings. And we use those tools to take a look at an existing structure. And all too often, the results of that kind of study are just very unsatisfying and unsatisfactory, because we see a timber structure that often is doing quite well, and yet per our numbers it doesn't meet code. And where are we supposed to go with that? Are we supposed to spend money reinforcing a structure that doesn't appear to need it? So the problem has been this, that we have been using the wrong tools, the only ones we know, but maybe a better way to say it is we've been expecting the wrong thing from those tools. You see, the National Design Spec and all the grading rules, all of that stuff is intended to be used for design of new buildings, where the sticks are still at the mill, they haven't been put into use, they may not even know how they're going to be used. We can know so much more about the lumber and timber in an existing building because we can look at it and we can know its species, we can know its grade, we can know its condition, how it's being used, whether it's a joist or a beam or a post. And we can see where the defects are, whether they're significant in significant places. So that's what this document picks up on and helps advance. So it'll help all of us do a better job. And for you owners, it's certainly part of the conversation you should have with your consultants, because it is a game changer. And let me spend this hour then, or 55 minutes, taking you through it. This was presented in January of 2019, this document. So it's been out for a couple of years, but still relatively new. And this is our first edition. We hope we'll continue to develop it. Our group, the Timber Frame Engineering Council, is a subdivision of the Timber Framers Guild, and we work in particular to advance the technology, the science of timber frame engineering, and try to bring traditional all wood heavy timber construction into the modern building code fold. So that's our background. The guide itself builds on some work that started quite some time ago. One of our co-authors, Ron Anthony, prepared this grading protocol for lumber and timber in historic structures back in 2009. And he did this as a grant project for the NCPTT, that's the National Center for Preservation Technology and Training. And then Ron joined our engineering council group in 2013, and we built on this, made it broader, more technical, but also more powerful. So we'll have kind of an overview here today of the document, and I will try to keep it not overly heavy on the technical side, but to let you know what is behind all this work that we do as engineers. We're going to take a look at the difference between designing new structures and evaluating existing. We'll take a look at timber grading and what the reason is behind the rules and what makes grading then of existing timbers different from what the guy at the sawmill is doing when he's grading sticks and why it has to be different. We'll take a look at how those values in the code were developed and then how we can learn to do some of that for ourselves to customize stresses. And then I'll take you through a couple of case studies to show how I have used this document to provide good results for the owners. So existing timber structures, well, wood gets used in many different applications, and it could be aqueducts and all sorts of air handling, cooling tower, I mean, you name it. But for this group, we'll focus on buildings. And so we're probably talking about maybe old timber barns, could be old timber framed residences if you're far enough out in the east. Quite often we're looking at industrial buildings, manufacturing facilities, warehouses, and so on. So inside, you could have your basic standard type 4 construction, as it's called in the code, where the exterior walls are load-bearing masonry, and then inside you have all heavy timber construction, where even the joists are more than 6 inches thick. More typically, we run into kind of a hybrid where we have heavy timber posts and beams, and then we use dimension lumber joists. But the guide applies to this type of construction. So the purpose in putting this together, of course, is to provide guidance to engineers and then through association to architects and owners and developers on a better way to perform structural evaluations of these existing timber structures. And importantly, it's to establish a standard of practice that we all can look to and use as support for what we're doing, because there hasn't been one to date. We've been a little bit kind of floundering on our own as consultants, as engineers. So what we do with this document is we bring together under one cover the idea of condition assessment, for which there are many publications out there, but we tie it together with determination of these mechanical properties that your engineer is going to be using to calculate the capacity, the strength of the building. So I've referred to the National Design Specification for wood construction. That's this green cover document in that particular edition. And this is these are the rules for designing in wood, and they're formulated by the American Wood Council, and they are referenced into the Michigan Building Code, and which is the National Building Code in effect. The NDS, as I'll call it from here on out, is really historically it's been subdivided into a number of small volumes. And so the rules themselves for design are in the spec, which is here in the front. And then behind it, you see a volume called the supplement. And in the supplement is where we find tables that tell us for a given wood and a given grade what the allowable stresses are that we can use in design. So an entry from that table looks something like this. You start with a species, in this case, red oak. And then for that species, we have three different grades. We've got select structural, which is the best, and then number one and number two. And each of those grades then successively allows more or larger defects, and so is less strong. So for any given species and grade, then you read across horizontally and you get various values for bending strength, for tensile strength, for crushing, compression parallel to grain, and so forth. So those are the kind of values that the engineer will refer to in running calculations. So those numbers are provided to the AWC to put in the book by the rules writing agencies, the grading agencies, and those folks have done us all a service by creating some order in what would otherwise appear to be the chaos of lumber quality. And no two sticks are alike because they come from trees, and trees, no two of them are alike. And so we have a wide range of characteristics, but the grading rules allow us to lump these various qualities into basically three groups that we called select structural, number one, number two. And then that just helps with marketing, with design. We can rely on those grades to assure us that the lumber that's being used is of a certain standard that will work for our application. So that's good, but before we get to that grade and use it to establish our allowable stresses, it's important to remember we need to know the condition of the wood as well in an existing building. So condition assessment is going to be our first step. I'm borrowing some slides from my colleague, Ron, and this first one is of a 900-year-old church in Prague. And the point of showing you this is to say that a timber structure, provided that it is protected from moisture, from bugs, from fire, from overloading, and from human beings in the form of people with sawzalls and drills and other things, really there's no end date for its service life. If it's protected and not overloaded, it can last indefinitely. In the real world, most buildings are used hard and put away wet, so to speak. And so we have damage possibly at locations due to rot, due to insect attack, and due to mechanical alterations, as we call them. And so the process of evaluating, assessing condition is to a large extent just determining where the wood is missing, where is it gone as a result of these past experiences. So we go in and map out where that damage has occurred. Now, part of our job then is to sort out what looks kind of crummy from what is actually seriously damaged. And so water staining is not uncommon, but water staining may not be an indicator of actual damage. On the other hand, on the right, crushing at the bottom of a post, well, okay, something's gotten kind of wet and soft down there, hasn't it? And so we'll map out where we expect repairs to actually have to happen prior to even considering what's left. So where are you going to look? You're going to look for places where wood is in contact with moisture, where it's buried in masonry or in contact with ground, where we can see visible decay and so on. And as part of that visual review, we may be prodding and poking with an awl or an ice pick possibly. And in this case, we're just looking at some bug-ridden floorboards, but then that could prompt us to look in more detail at the underlying framing. So a couple of different ways we might go about quantifying damage. in sort of a very mildly destructive test, we have drilling techniques. This is resistance drilling shown here, a kind of a sophisticated drill, you might say. It pushes a probe into the wood and measures the resistance as a function of depth, and it records that for you. So you can kind of map out where there might be voids or soft spots inside of a stick. And you notice over here on the right, Ron Anthony is probing near where joists enter a masonry wall, where he's suspicious that moisture damage and rot may have developed. That particular gadget can run, oh, even, $9,000. So a more accessible tool is simply a small cordless drill with a 1/4 inch diameter tapered bit on it. And so we can drill into a timber and just subjectively assess how hard is it to push in, where does it get easier, what are the quality of the shavings coming out? Are they nice and rich and full, or are they dusty or even nothing coming out? Well, that's an indication of trouble in those cases. So that's kind of looking back at damage that's already happened. And then we can kind of look forward a little bit by using moisture diagnostics. And in so doing, what we want to determine is whether the wood is dry or not, because dry wood will not rot. Wet wood damage will continue to accumulate. So the magic number is basically 20%. If wood is drier than 20% moisture content, no further deterioration will occur. On the other hand, if it's greater than 20, it will continue to rot. And so that's a sign to us that we need to get in and take care of some preventive measures to stop the roof from leaking, to prevent water from wicking up from the foundations, and so on. So moisture diagnostics are part of that assessment. All right, well, let's return to grading for a minute. And why do we grade lumber? Why get into all that mess? Well, it's required by code for one thing, and that's just a basic um, a safety measure, a quality control measure to make sure that poor quality lumber is not being used where a better stick is required. And unfortunately, the old timbers in barns and warehouses and so on, there are no grade stamps. There's nothing to tell us what the species is or what quality the wood was. So we need to do it. We need to know that grade to be able to determine our design values, our allowable stresses, as you saw in the NDS supplement. Now you wonder about other options for determining strength of existing buildings, and destructive testing kind of comes to mind in steel structures, concrete structures. We're very used to cutting small samples out of the beams or the floors, and we take them to the lab and we crush them or we stretch them until they break, and we get some idea of how strong that material is. That doesn't work well at all in timber structures, because if you go in and start cutting out samples of wood, and these need to be, 2 inches square by 30 inches long, I'll call it, for testing, you're only testing the wood of the stick, but you're not testing the whole stick. You need many, many samples, first of all, to get even a statistically meaningful representation, because no two are going to be the same. But you're missing the point, which is that the strength of the stick is largely governed by the defects that are in the entire timber, not by the strength of the wood where it's all nice and clean. Full-size lumber and timber contains natural growth characteristics or defects, and those are what really drive the allowable stresses that we use. So destructive testing is really not a good option. We'll end up destroying the building that we're trying to preserve. Referring back to historic data for allowable stresses is kind of intriguing, because sometimes we see higher values in the old tables than we have in our current specification. The problem there is you need to know how those numbers were developed. What was the testing protocol? Did they test wet wood or dry wood? That makes a big difference. What were the grading standards? Grading rules have not stayed static over the last 100 years. They have evolved. So what is a more reliable approach is to use our visual grading techniques and the current grading rules to establish our grade. And then that dovetails into the development of allowable stresses that is permitted by our current building code. So it's our best direction forward. So to develop our design values that we're going to use to calculate the strength of the building, we need to know the species of wood or the species combination that it falls in. We want to measure the actual dimensions of the sticks that are used, so we know the true cross section. We need to identify the defects and then we measure them. With that information, the code tells us that we're allowed to assign design values, allowable stresses. So that's why it's important. Let's take a look at that first step, the species identification. This is a photomicrograph of a piece of elm. And right away, you get the idea that wood is not a homogeneous mass like a piece of plastic. It has a lot of character, and that character is what we'll rely on to find out the species. So that's a little look ahead here. Uh, Getting your species is the starting point, of course, for determining your design values. And I continue to say it's irresponsible for any consultant to walk into a building and just guess. It's irresponsible because the range of mechanical properties for different kinds of wood is very great, from the weakest eastern white pine to the strongest white oak. That's a factor of two. It's not splitting hairs here. There's a big difference. So it pays to know what you have. If preservation is your goal, you're not trying to give it the least strength. You're trying to find the greatest reasonable capacity for that existing structural. So you avoid unnecessary expenses and you avoid goobering up the building with a bunch of reinforcements that might not be necessary. If any of you are woodworkers, you might already have some capacity to look at boards and you know white oak or red oak or walnut or cherry just by looking at it. But our problem when we get into existing buildings is that usually the surfaces are very rough. They're rough sawn, they might be hand hewn even. They're dirty, they're stained, and not uncommonly, they've been painted. So we're not able to see those grain characteristics that we would often rely on just to eyeball what the wood is. So we need to go inside, as I say, knock on the wood and ask the spirits to come out. And what we do is we use the physical properties of the wood and we look at the wood anatomy. This is something that actually you can learn to do for yourself if you're interested. Hoadley's book, shown here on the left, is still just a really good starting point to learn how to do this. And I will say it takes time to learn and it takes some practice. So in the meantime, you still need to know what kind of wood you have. And so you're going to be needing to submit samples to the Forest Products Lab in Madison or find a service online that will identify the wood species for you. But just to give you an idea of what's going on there at the lab, um, a lot of hardwoods have very interesting characteristics that are visible right on their end grain, and they will actually give you enough information quite often to make a determination of the kind of wood. So that's what Dr. Hoadley's doing here on the left. He is using a small handheld magnifier, just a 10x magnification is sufficient to look at the end grain of a piece of historic furniture there. And he might be seeing something like this photo that you have in the middle of the screen at the top. It's tells you right away there's a lot of information on the end grain. It's a very complicated arrangement, and that arrangement is specific to a given type of tree quite often, but not always. Particularly softwoods and some hardwoods, we need to go further, and we'll use the microscope to start looking at the actual details of the fibers in the wood and how they grew. And so with the microscope, you might get views that look more like this thing at the center in the at the bottom, and that's two views actually. One is an end grain and one is a tangential section. But that's what they're doing at the lab. They're looking at the individual cells quite often to figure out what kind of wood you have. We all need to be able to send them samples, and this does not need to be a destructive process. The samples that you need are small, just the size of your little finger. And so we can look for places to take these samples that are invisible or very modestly visible and don't damage the structural member either. So we might go to the tops of beams or joists out near their ends where that loss of wood is going to have no effect. We can go to the top or bottom of posts. And what's really handy is if you've got existing notches, you can take samples adjacent those. The damage has already been done. You're not going to hurt anything. So that's what's going on with wood identification. So once we got our species, now we're ready to start turning to the grading rules and figure out what grade we have. This is the Northeast Lumber Manufacturers Association, and there are other rules writing agencies around the country, Western Wood Producers out west, and there's Southern Pine Inspection Bureau down south, and so on. They're all pretty much the same. They vary only in some minor details. This is a page out of one of the grading books. Don't try to read all this, but the point is that for a given grade, the rules identify a number of characteristics and tell us what the maximum size or number is of a certain characteristic. So a lot of the rules, even though these are structural grades, so-called, a lot of what the rules address are things that are quality control and marketability driven. Warping, wane, that is there bark on the stick? Did the planer skip across the surface, or did the saw tear up the grain? Are there shrinkage checks present? Stain or pitch streaks? A lot of those have to do with appearance, frankly. When we're in an existing building trying to determine what matters, really all we need to look at are the knots and the slope of grain. So knots are a bit of an issue for us because they interrupt the straight parallel flow of the fibers parallel to the direction of the stick. And so that deviation of grain creates a weakness in the stick. So we look at the knots and the size of the knots and the location. A knot near the edge of the piece is more deleterious than one that's in the middle. Bigger knot is worse than a small knot. We don't need to look at every single knot. We just look for the biggest one in the worst place. And that's the nature of grading. We think of timber and lumber as if it were a chain. And so we're trying to find the weakest link. And the weakest link occurs at the worst knot. So all we need to do is find that one worst case in a whole stick. And that kind of speeds things up for us, of course. Slope of grain is something that the old timers didn't really appreciate, I don't think, so much. We go into buildings with beautiful southern pine lumber, not to be found, but quite often we got twisted trunks and slope of grain. And that slope of grain is a real killer because if those fibers in the wood are not parallel to the stick, it creates tension perpendicular to grain when the stick is subjected to bending. And wood's not strong perpendicular to grain. It's strongest parallel to the trunk, parallel to the grain. That's the way it grew in nature. So if you have just a 10% slope of the fibers relative to the axis of the stick, which is a 1:6, you lose 50%, actually more than 50% of the strength of a straight grain piece. So that's the limit for number 2, 10%. You have to be better than that, or 10 degrees. You got to be better than that to be select structural. So that's what we're going to look at. Now, to be able to do that, we need to have access. And this is an important point. You can't go into a building where the floors are all finished and the ceilings are all finished and the columns, the posts are all buried in walls. You you have no opportunity to perform visual grading. So you have to have access, can't have too many interferences. If things are painted, it doesn't help. One or two coats, probably not a killer. Usually the grain characteristics kind of telegraph through the paint. We can see checks and we can see knots. 10 coats of paint or more, yeah, we may have a problem. You need to have good lighting, of course, that can be provided. And then there's the question of how much do you need to grade, the sample size. Uh, when it comes to posts or other critical elements, really you do want to be able to grade every single one in the areas of concern. Beams, pretty much, it's nice if you can look at every single one. You certainly want to look at a good percentage. Now, joists, of course, you could have hundreds or even thousands of joists in a building. And we don't need to grade every single joist in the whole building. We'll take some representative sampling. How many? Well, as a kind of a guideline, you might say 25%. If you've seen 25% and you see a consistent pattern, I think it's reasonable to extrapolate from there. And so that'll be the strategy we'll use. So if somebody cuts a hole in a ceiling somewhere and says, stick your head up and take a look and tell me what we've got, you might see something like this. I can see one side of two joists for part of their length. And what I'm seeing here looks pretty good, but how much confidence can I have that this is representative of the rest of the building? Not much until we do quite a bit more sampling. So you can learn to grade lumber for yourself, just as you can learn species identification. But again, it takes time, takes practice. And most people aren't comfortable with that anyway. So you can look online for assistance with grading. You can dial up the NELMA folks, that is the Northeast Lumber Manufacturing Association. They have graders in the state of Michigan. TPI, Timber Products Inspection Services, is another resource. They will help you with grading in situ. Well, now, okay, let's say we've done our condition assessment. We've got our species and our grade. We've got all of our member dimensions. We know the spans and spacings, and we know what the loads are that we want to subject the building to. It's time to start running some numbers. And to really come up with an answer for an owner as to how strong is your building, we got to have allowable stresses to apply. What's the limit to which we can press these sticks of lumber? So we've got options. We can go straight to the NDS supplement that you saw before and read those books right out of the read those values out of the book that are intended for new design. Or we have this other option of developing design values from scratch using the same standards that were used to create those NDS supplement values. So several good reasons for using D245, and one is that it will provide us a code recognized method for developing these values for species that aren't in the NDS. That book is set up right now for what are considered commercially viable species, and there's quite a few in there, but historically we've used quite a few more species than are currently found in that code book. So just for example, you can find beech and maple and oak in the NDS, but you will not find ash or elm or basswood or any, dozens of others, frankly, that we run into all the time in buildings, particularly predating 1900. The other thing is that in the NDS, they tend to lump species together into marketable groups, categories, and species combinations, they're called. Usually within those species, there's kind of one weaker species that tends to control the value for the group. But if we've got the best species within a given combination, we can use D245 to tailor the allowable stresses to that species. So that's pretty handy. And then really very significant in a lot of old industrial buildings is where we have high quality timbers, southern pine or Doug fir, that are better than select structural. We can develop allowable stresses that are in turn better than the values in the book for select structural. So we can get more bang for our buck this way. I'll tell you how it works is that since 1920, the Forest Products Lab has been testing sticks of clear, straight grained lumber from all the different species in North America, or a great number, about 100. And that testing is done on many samples because wood is highly variable. You need to test 50, 60, 100 pieces before you have a statistically meaningful set of data. All that information has been tabulated and presented in this ASTM standard D2555. So for basswood or beech or birch, we have values for bending and for compression. And we also have a standard deviation for the results. And that is the information that we use as our starting point for calculations. If those 100 or so species in the D2555 aren't enough for you, you can go to the Wood Handbook, which is from the Forest Products Lab. And there are even more in there, like honey locust and black locust and magnolia. So the information's out there. We don't need to do any testing in an existing building. We're just reinventing the wheel, only not as good. So go to the standards where this information's available. And then we can take this D245 document. This gives us the procedure for taking strength testing data and turning it into our allowable stresses. So I'm not going to go into the gory details here with you, but just to let you know, there are 4 basic steps what we do. We calculate a lower safe bound from that testing data that we got from D2555. Then we apply safety factors and we apply strength ratios to account for knots and slope of grain. So that's that thing where we need to look at the whole stick. And then there are some other modification factors for whether it's being used flat or standing up on edge, whether it's got fire retardant treatment or not, and whether it is wet or dry. So I'm going to look at 2 of these things with you in just a little more detail. The 5th percentile exclusion limit. Remember, this wood is statistical stuff, and we've got a range of strengths for these small, clear specimens. You know, it's not a matter of grade at this point. It's just the variability of wood itself. And so we need to make a decision, what's the right number to use for developing design values? Well, traditionally, we go to a near minimum strength. And it looks something like this. You know, if you had a whole bunch of tests for hemlock, they would all cluster around some mean value, some average. But as you move away from that average, you have other test results and they get fewer and fewer as you go towards stronger and weaker. So the industry standard had always been that you pick a value such that 95% of all the test results were as good or better. And that is considered the standard of safety that's acceptable. Now, what that means in practical numbers is that we're going to use a value for bending or for compression that is about 75% of the average strength, which in turn is really only about, let's say, less than 50% of some of the very strongest wood you tested. So in this measure, in this effort to be safe, to be conservative, we are leaving a lot of strength on the table. And you kind of wonder, wow, really, we got to throw all that away? Isn't there some way to test the piece and to know? And as I said, not really. You have to destructively test the whole stick, and that doesn't really get you anywhere. And even non-destructive methods are not particularly helpful because they really measure stiffness of the wood, and there's not a very direct correlation between the breaking strength and the stiffness. So they're not particularly helpful. Turns out that really our visual grading and using this method is the most effective and reasonable approach. So that's the fifth percentile thing to keep in mind. That's behind all the values we use. The other thing is that wood gets stronger as it gets drier. And all the lumber you buy from the store has been kiln dried down to 19% moisture content. So those design values that we find in the code take that into account. They say, all right, well, if you're down to 19%, you can use a higher value than you would for green, unseasoned lumber. They don't do that for timber. If you've got stuff that's bigger than 6 inches in its minimum dimension, if you've got an 8x8 or a 10x14, the code says you use the unseasoned green values. And they say that because, remember, they're in a new design situation. They haven't seen the stick. They don't know how it's going to dry. Maybe some defects are going to develop. It's going to shrink and get smaller. So as a conservative approach, they say, we'll just take it as green. But that's not reasonable for an existing structure. I can look at the stick, I can measure its cross section, and I can see whether there are defects present that were caused by shrinkage. And if there aren't any, or if they're insignificant, it's very reasonable to start assigning some increase to strength. And so we're saying in our TFEC document that that is a reasonable approach, and you can increase 25% for bending, for instance, and even more, and quite a bit more for compression parallel to grain, like you would have in a stud or in a post. Well, let me show you what the actual net of all this is with a couple of examples. If we had an 8x10 beam that we grade out as number 1, it's in dry service, it's all seasoned, and maybe its edge knots are a little smaller than the ones that would be permitted in grade, and that's usually the way it is. If we read the value out of the book, for instance, for bending, which is that first column under F sub B, the book would tell us to use 1150 PSI. If we calculate it for ourselves, we can jump that by 50%. So that's a significant bump up by using this approach to developing allowable stresses. Here's another example with some really nice old southern pine, old growth material, straight grained, again, small knots and dry. If we read a value out of the book, it would tell us 1500 for bending under F sub B. We can calculate a value of 2275 PSI using this method. So again, about a 50% increase. Darn helpful when you're trying to avoid unnecessary repairs. And let me take you back to a situation where, let's say you have an investigator comes into a building and doesn't know the species and doesn't know the grade and doesn't have any real appreciation for why those things are important. They want to pick something that they think is safe, and so they'll say, let's grab something that's familiar. Let's call it SPF number 2 or Hem-Fir number 2. Those are some species combinations that are kind of garden variety for designing new stick-framed residential construction. So they grab something they know. Well, if you read the value out of the book for this Hem-Fir number 2, you would see a 675 PSI value for bending capacity. If you actually had that really high quality southern pine and calculated your allowable stresses, you would be able to use 2275 PSI. That's a heck of a difference. By making what I'll call a silly assumption, because you just didn't know better or didn't want to take the time and trouble and expense, well, you threw away nearly 75% of the strength of the building. And I'm not making this one up. This is from an experience I had when I was called into a building. So we were able to reduce the expense to the owner considerably and do a far lesser amount of strengthening and replacing of material. So whether you're a consultant coming in to assist an owner or you're an owner looking to hire services, look into this document. It can be a great help to you. It's been a real game changer for me in my own work. And let me show you an example of how I used it here. The Hannah Lay building is right downtown Traverse City. It's right on the historic strip with all the restaurants and stores. And the owner is also a developer, and he wanted to add another floor to this 3-story building. So he wanted to put 4 over 3. And he was concerned about the capacity of the posts in particular, where he was going to be adding these extra loads. Just by way of background, Hannah and Lay were these Chicago gentlemen who came into Michigan as businessmen, and they were lumber barons. And this is what their mill looked like right at the mouth of the Boardman River in Traverse City. So you can see Traverse City wasn't always quite so picturesque, but this was right downtown Traverse City. I kind of love this picture. Well, they got involved in Michigan in the 60s and 70s, but by 1880, they were starting to see that apparently the forests of Michigan were not inexhaustible after all. So they started to diversify, and they went into real estate, and they got into commercial enterprises. And so they built this big store building in 1883. And most of that building still survives today. It was the biggest thing in northern Michigan at the time. Well, step one was then we got to know the species. So I gave the owner guidelines on how to collect samples, and they went through and did that sampling up in areas where it wouldn't do harm and wasn't visible. They sent those to me, so I had a chance to look at those before I'd even been up to visit the site, and I knew then that we had red pine for all of our posts. Next step, we want to determine grade. Well, this was their situation. The posts were partially embedded in partitions, but I could see 2 faces very well. So that's a good starting point. And what I saw was incredible quality timber. It was perfectly straight grained, and there were almost no knots. So, well, that gave me confidence that we had some pretty good material. But to confirm, I went to other parts of the building because I wanted to see the consistency of the quality in the building. And it turned out it was very consistent. These lumber barons apparently saved some pretty good material for their own building. And so as I went around the building, I could see that we had incredible quality material. Growth rings of 30 plus per inch and knots that were typically on the order of 1 inch, 1.5 inches, and smaller. So insignificant. We had material that was better than Select Structural. So then I proceeded to calculate design values for this, call it ultra select material. And here's the results. I came up with some recommended values for them. This FC that you see here refers to the compressive stress that we're going to use for compression parallel to the grain. So that's what the posts are going to feel. And from the book for a Select Structural, you would get 775. I gave them a value of 950. So we've got about a 25% increase. The thing is, we could have gone higher because I was only using a 10% increase for dry service conditions, which is the same as the code uses. But I didn't take any further increase for seasoning. If I had continued on with the calculation, we could have been discussing a compressive stress of almost double what's in the code book. As it turned out, they were good to go with the 950, so we didn't have to stretch things any further, but I would have been willing to go there. So this shows you an example of the value of this technique. And when it all works out nicely, that's great. It in real life often does not work out this cleanly. Obviously, you're going to use these methods if you're wise and want to see what the maximum reasonable value is you can get. And the other thing we can do in our grading is, as I said, we can look at where these grade defects occur. And if you have a grade limiting defect that is not located in a highly stressed part of a stick, we may tend to discount it. Whereas the guy grading lumber at the mill does not have that freedom at all. If a knot is at the end of a stick in a place where it really doesn't matter, it doesn't count. In the grading rules, that stick is downgraded. We in the field can make some judgments. And if we have a few pieces of lumber that aren't so great, we don't need to let them control the value that we're going to use for the whole building. You know, just as in grading, the weak link is what controls for an individual stick, also for a building, then it's the weaker material that governs the design values for the whole building. Well, we can do some selective strengthening. And by doing so, we can upgrade then the value that we're going to use for the rest of the material in the building. One thing I like to make at least the consultants consider too is that even if on paper, after all this, you're still seeing a little overstress on paper, it doesn't mean that you have an unsafe condition. If you are seeing good performance and you have a history of use in this building, what's happening is you've got sticks that have been load tested. And so you have to think back to that 5th percentile lower bound. The sticks in the building may be telling you that that 5th percentile was an overly conservative assumption for the material in this building. And that's where the observation of performance is so important. So we can use engineering judgment to decide whether a little overstress is a deal breaker or not. And it need not be. On the other hand, don't ignore trouble. Sometimes in our enthusiasm for preserving that historic fabric to the max, we want to grandfather the whole building in and just say it hasn't hit the ground yet, so isn't it okay? I don't consider that reasonable. If you go into a building and you see broken joists or badly sagging floors, that's an indication of probable trouble. And if you've got signs of trouble, and if the calcs aren't bearing out for you, then you probably need to do something. I think you must. So let me give you one more case study. And this was a major rehab here in Grand Rapids, 50 Monroe. This is an older picture when they were just getting started, had just stripped off all the metal siding to expose the brick. This was an 1880 building, and it's one of those combinations of heavy timber and then dimension lumber joists. And their challenge was that they'd gone through and done a little testing. The engineer involved had identified eastern white pine and eastern hemlock. And he had determined that he needed an allowable bending capacity of 1250 psi. Well, for eastern white pine or hemlock, that means you got to have select structural material, and that was not the case. As you can see here, not all the joists were select structural, and slope of grain is causing splitting and fracturing in this joist right in the middle. So the engineer was coming back to the owner developer saying, I think we got to replace all the floor framing in this whole building, all stories. And naturally the owner was a little back on his heels with that one, but they gave us a call, and I said, I can't promise anything, but I'm happy to take a look for you. So we did more species testing, and we found that actually eastern white pine was in the minority. Most of the building was hemlock or red pine, and those two are stronger than white pine. We graded sample areas to come up with some idea of what the quality of material was. It ranged quite a bit, but actually most of the stuff was select structural. And Then we developed reference design values, calculated out those allowable stresses. So I was able to come back to them with a recommendation that what we need to do is on the first floor where you want to have assembly loading retail 100 pounds per square foot, all we need to do is get rid of all the number 2 material. Anything that's number 1 or better is going to be okay. So the owner said, well, okay, why don't you come in and grade all the joists on the first floor then and tell us which ones we need to remove or strengthen. And we did that. The way it worked in this building, for some reason, they would get a bad load of lumber and it would all get used in one area. And those areas that were bad were really bad. And we did say, go ahead and take those out and rebuild. But in the rest of the building, if we had a piece of number 1, it was quite often just mixed in with a bunch of select structural. And if we had an eastern white pine stick that was number 1, it was often surrounded by select structural hemlock, which was more than strong enough. So for that eastern white pine number 1, maybe on paper we're a little overstressed, 10, 20%. But as a practical matter, the whole thing is good. It's got more than enough capacity. So we told them to proceed on that basis. So it was a really good result for them and kind of saved the project, really. So to wrap up here, I see we're at the top of the hour and I've got just one more thing to share with you, and that is that you can turn to the Timber Frame Engineering Council as a resource, and you do not have to be a member to access the documents if you're interested in learning more. Your membership is encouraged because it will support the research work we're doing. And you will also be alerted as to future educational offerings because we will be teaching wood identification and lumber timber grading, non-destructive evaluation methods. We've got some stuff coming up this August. And then I teach wood identification every year at Tillers International in the Kalamazoo area. So Mallory's going to share some links for all of this stuff with you so you don't have to write this down right this minute. Here is my contact information. And if you have other questions, you can shoot them to me later on. But for now, Mallory, I'll turn it to you and you can start letting us know what's on people's minds.
Yeah, we've had several questions come in. I did note this in the chat, but we did go right up to 2 o'clock. Tom has generously offered to stick around to answer questions for as long as needed. But if you need to hop off, thank you for attending, and all of the questions and Tom's answers will be in that recording that we put up on YouTube, and a link will be sent in the follow-up email. So thank you for attending, but if you want to stick around to participate in the Q&A live, we hope you'll stay with us. So we did have some good questions. I was watching them come in. So I will start at the top. It is great that these lumber standards are integrated into the national and state building standards. We find, however, that they are interpreted at the local level in a very conservative manner. What is your advice?
Right. I think it's a matter of education. And as I say, this is partly why we developed this document. We're trying to set a standard of practice for the industry. So as you approach a building inspector, I think you have to inform those folks as to the background. I mean, obviously you have to convince them of your expertise, what your training is, what the basis is for making such claims. And at that point, it becomes a matter of discussion. I do know of some actually major municipalities that have said, I don't really care about all this stuff. We're going to take it right out of the book. And that is wrong because the building code itself says we can do this. So if a building inspector will not even comply with his code, I mean, obviously something's wrong there. You have to decide whether to fight or grin and bear it. But that's my answer to that one, is that it's a matter of education and showing that inspector, that building department, what's going on behind the scenes, what's in that book, why is it there?
Sure. Excellent. And I mean, that goes back to, right, all of our basics in historic preservation, right? Educating those who are not familiar.
Mm,
And this is just another opportunity for us to have those conversations with people. So thanks, Tom. Are there seasons or weather conditions when moisture diagnostics will be thrown off because of temperature and or humidity? You ever have to think about that?
right. Well, the appropriate moisture meter to use is one with prongs that go down deep into the wood. So you're not reading the surface moisture. If you have one of these little moisture meters that doesn't have any probes, it just reads. There's two types of meters. One's what do they call it? Capacitance and then resistance. But anyway, what you're looking for is a meter that sends probes down into the wood to a depth of, say, an inch, even an inch and a half.
Okay.
Or there are types that you can drill holes into the wood to get down that inch and a half or 2 inches. At that point, you're reading more of the equilibrium moisture content inside the wood and not just a surface condition that might be passing. So that's how you get past that one.
Okay.
Temperature, well, I don't know how well these things work below freezing. I think they're still valid, but maybe not as. There is some temperature effect. But otherwise, yeah, humidity changes. I mean, the weather's always changing, but wood is rather slow as you get
Mm,
deep to change with those humidity changes. So you're interested in what's going on a little bit deeper inside the timber or
mm,
stick.
right. Excellent. That's helpful information. We have historic structures from the 19th century that are petrified to the point that a fire in the building was self-extinguished. How is that level of aging factored into structural calculations? And then there is a note that says there is some crumbling of the foundation stone at a corner. And would this additional hardness of the timbers make the foundation issues mute versus expensive replacement of the foundation area? So a couple of things going on there.
Yeah. Well, it does kind of go back to that point that as wood gets drier, it gets stronger. And provided it is not subjected to long-term moisture, water attack, or bugs, that strength is going to remain. Again, provided it's not overloaded. So it may be you're looking at a situation where you really do have good bone dry timber, and it may be of very high quality. And so it is quite hard. It's also a function of species, of course. I mean, cedar's never going to get any harder no matter how long you wait, whereas oak and southern pine and Doug fir can get harder than steel. So that would be something for you to take a look at, is what kind of wood do you have. But yeah, the drier it is, the harder and stronger it is. And so that could be what you're seeing there.
And then in conjunction with the crumbling foundation stone, the question of would the hardness of the timbers make the foundation issues mute? Or would you recommend that they have someone come out and assess that foundation?
Oh, well, I think, yeah, you'll certainly have to take a look at the foundation and how a loss of that foundation might affect the stresses within the structure. Are you going to
Mm,
start to see sagging? Are you going to start to see joints breaking? Quite often that is the case. So you'll undoubtedly want to reestablish that support and not ignore it.
thank you. What is the best bit of graffiti that you have found, or the best message an earlier craftsperson left for you to find as you're crawling up in joists in buildings throughout Michigan?
What was the first part of that, Mallory? What is the
What
best?
the best bit of graffiti? So like
Graffiti.
markings on the timber, or something that you found that sticks with you. Maybe that's
Uh-huh. Well, besides the occasional florid signature with a date, the saw marks are a sort of graffiti, you might say, because you all probably know that back in the early days of pit sawing or frame sawing at a mill that was water powered, the saw blades worked in frames that simply went up and down. And so the saw marks left in the rough sawn timber are perpendicular to the length of the stick. They may vary just a little bit off perpendicular as the frame was raised and lowered, but they're nothing at all like the marks left by a circular saw, which clearly show a radius sweeping across the face of the stick. So those in turn can be some indication of how old might this building be? When did we start getting circular saws in this particular region? So that comes to mind.
Interesting. Yeah.
Hand hewn, of course, is a signature of sorts. And when you find old buildings, of which I saw a couple just in the last week or so, where even very small sticks, 4x4 and 5x5 in cross section, had been hand hewn, uh, that's a likely indication of some real age,
Mm.
as in pre sawmill availability. People would not bother hand hewing such small sticks if they had a mill in the neighborhood. They might only hand hew the very biggest timbers that were just too darn heavy and long to try to take to a mill. So those would be hand hewn on site. But small stuff, you could run down to the mill, get it sawed, and save yourself time and trouble. If that wasn't done, it gives you some idea of where you might fall in the historical development of the area relative to European settlement.
Right. Right. Excellent. That's really interesting. An interesting thing to think about left behind on those wood frames.
Mm.
What kind of impact is climate change having? Like, is there impacts on the ideal moisture content? Have we been seeing new types of insect infestations in their timber framing? Anything?
Yeah, nothing's come to the surface in that way to date. The things that are of interest to us really aren't affected much by climate change per se. I mean, I suppose more termites migrating further north is never going to be a good thing. Um, but no, nothing in that particular area. It has and is making a difference in the ways trees grow. And
Mm.
so it will have future effects on lumber harvested as the years go by. And there's a great deal of research ongoing in that department right now. The wood anatomists are studying very carefully the changes in growth of wood with changing climate and how that affects the quality of lumber. But for our old buildings from the 1800s and early 1900s and so on, I don't think that's a factor yet.
Um, do you think there are enough younger people coming into the field to allow historic wood buildings to be understood and conserved? Who is training them and who is hiring them? We look to the future.
Yeah, it's a great question, and it's one that concerns me. I'm probably not in a position to be able to answer it very well, but I certainly empathize with our need to get younger folks excited about the craft and the quality and the history and the mindset of the carpenters and designers that came before us. That's been a fascinating thing to me, and I just stumbled into it as a college dropout working on remodeling of old buildings, and so it got under my skin. And yeah, I would just wish everybody had a similar opportunity to get enthused about the real lumber and the real craftsmanship of those old buildings. But how do we get them going? Well, I'm retired here now, so I'm not going to be able to directly impact other than sharing, and that's what I'm doing here today.
Yeah, or I mean, you teach those classes at Tillers International, the timber framing, and they do a lot of old skills. So maybe if there's a young person in your life, you can purchase them a nice gift certificate to go take a class at Tillers, and
Excellent thought. Excellent, Mallory. Thank you.
or have them attend our conference or one of our hands-on workshops, and
Hmm.
that we'll host in the future. So
Right.
definitely something we as a field should continue to think about, lifting up our young people so that we can continue to pass on this knowledge. A few more questions.
Okay.
We had a lot come in, so this is great. Do barn structures usually have a certain species of wood for sill beams as compared to the posts in Michigan that you've seen?
hmm Well, they should, and they don't always. We have come across eastern white pine being used for sills, and white pine is okay for siding, but as a sill, it's really not a very durable material. I have seen quite a bit of poplar used, yellow poplar, it's called officially, but tulip, and that's a fairly durable wood. Again, really great for siding and other things. Perhaps the best is white oak, and I would say that is the one that dominates for sills. The sills were often meant to be very heavy timbers, and white oak is heavy wood, as you know, um, but it also is naturally durable. It does not take on moisture readily, and so white oak is your timber of choice. It's not used universally here in Michigan for barns. However, it was a function certainly to some degree as to, well, what do we have on the farm? I mean, we're going to use what we have, and if we have white oak, excellent, but may not be available. White oak doesn't grow in profusion as you get farther north.
Excellent. And then what species of tree is used in the posts, or is it similar? It's kind of whatever is on the property that.
Well, in fact, as you go back into the 1800s, that typically is the case. So in any one barn, you might come across oak and ash and elm, you know, oh, 5 or 6 different species used in posts. And some oddballs like basswood. Basswood used for beams and joists. And basswood is a very soft wood. It's nice for carving and things like that, and it would be fine for board sheathing. But to use it for structural members it always catches me by surprise. I keep thinking, no, wait, that has to be maple. But get looking at it closely, and it's basswood of all things. So you can run into all sorts of things. Now, as you get into industrial buildings, things that represent a little more advanced state of transportation, communication, we start to see more uniformity in the materials used. So you might have all the posts are red oak, and all of the beams are Doug fir or white pine. So as the lumber industry became more regular and commercial, we see more uniformity. But as you go back, you'll find there can be just about anything used in some of these old buildings.
Right. When people just are able to build what they can from what they have, right? Sometimes the end result is not what is ideal. But
It
it
gets it
serves
done.
it serves its purpose. um, a question, getting back to the code for a minute. Are you aware that people are trying to take R 104.10 out of the Michigan code, which makes it clear that the building official is allowed to approve modifications to the code? I am concerned that this may make it more difficult for a building official to accept alternative calculations. And then advocating, people who are listening to this presentation should contact their legislators if they are concerned that removing this paragraph from our code would be problematic. And most building officials do not want it removed.
So that's the residential code, I take it, and that's a bit more of a prescriptive code. I would think you could always turn to the regular building code, wherein alternative means and methods are built right into the fabric of the code and permitted. And that's what we're doing when we use this TFEC3 method. We're really introducing alternative means and methods and presenting those to the building official for approval.
Okay.
But I agree, it'd be a shame to try to remove any sort of judgment and flexibility from the inspector's powers.
Sure. Yeah, because everything local is, everything's a little different depending on what community you're in, and the history of the development. So we're on our last question that was submitted. So to those who are still around, if you have a question, I would suggest typing it in now. Otherwise, we'll close out after this one. What is your advice on getting paint off of wood surfaces so that the finish and grain aren't damaged? And assuming that this method wouldn't affect the strength of the timber.
And what is it we want to remove?
A paint or a finish.
paint,
So if
yeah.
you're trying to get to that grain, I think is what they're asking.
Mm-hmm. I think that is, of course, kind of a craft question, and one that is subjective as to the value of the answer.
Mhm.
You can sandblast, of course, and I've seen some pretty atrocious results of hairy looking things hanging up there. The grain is just torn up and destroyed, and even on some softwoods, it can cause actual loss of cross section. If you have bald cypress or cedar boards and sandblast those, you'll eat them right up. Of course, yeah, dry ice blasting or some softer media like walnut shells, I have seen used satisfactorily. You certainly will do some etching of the surface. So you'll see the late wood, the grain standing out in ways that wouldn't be apparent in a planed or surface board. But those don't look bad. So then you get into chemical stripping, and that's messy business too. So uh, I'll leave the rest of that to the craftspeople and the conservators. But my own opinion, when I'm working on small projects, I prefer scraping. But that's not practical for removing paint from a large uh, framed structure. So I guess the one I've been happiest with as a, call it a average, splitting the difference, is the walnut shell blasting, done carefully.
Okay. And then if you're in a situation like the picture that you have up right now on your end slide, you needed to identify the wood species and you just needed to access a little bit of it because it was all painted, you would just go in and scrape off that layer of paint so you could have a small area, or do you use like a one of those cobras? I know some people.
Yeah, I usually don't try to do too much scraping or planing on the material in the building just because it's still such a small little window and it may have too much stuff goobering up the appearance of the grain. So I will go to taking small samples,
Okay.
as I say, something about the size of your little finger, let's call it, and take it from a discrete location. And then I can look at that under the microscope or with a little handheld magnifier, and I can do a much better job that way than messing around with planes or scrapers in the field.
Got it. Okay. Excellent. Well, thank you for answering, sticking around to answer these questions and for um, sharing your knowledge with us today. We're eternally grateful for you
Mm,
to host today. Um, Again, thank you to our sponsors, the Michigan Council for Arts and Cultural Affairs and the National Trust for Historic Preservation. The remaining webinars of until up through the fall, so through September, are now live on our website, www.mhpn.org/workshops. If you want to register in June, we will be joined by the Bluebird Inn in Detroit, and they're going to talk about what they're working on. And in July, the Zeboing Center is going to be talking about their projects up in the Mount Pleasant area. So we hope you will join us. Again, registration for our conference is open. I do hope you will join us. If you can't join us live, those sessions are recorded and you can check them out through the end of the year. And it is going to be a phenomenal conference. We have a lot of great sessions. Just like we have in our webinars, we have such phenomenal talent in our state who are so kind to share it with us in these educational opportunities. So thank you again, Tom. Thank you all for attending, and we hope we will see you in our next webinar.
thank you.